Okay, this is going to be cytogenetics of lymphoma. So again, the pathologist, understanding the pathology first, this is, again, dovetails with the pathology. Lymphoma is defined as a discrete mass arising from lymph nodes. There are several lymphomas with specific cytogenetic changes, and these aid in the diagnosis and the type of lymphoma. I'm sure you've seen this same picture 100 million times because this is a picture we use for Burkitt's lymphoma. Non-Hodgkin's lymphoma was first described in children in Africa who had lymphoma in addition to Epstein-Barr virus, and this is known as endemic lymphoma. These are usually seen in children or young adults, and sporadic lymphoma is seen throughout the world. Non-lymph node tissue is also involved. So let's talk a little bit about Burkitt's. Burkitt's has a specific chromosome translocation between the long arms or Q arms of chromosome 8 and chromosome 14. And over to the right here, you can see the MYC gene, MYC, which is actually a really important gene in a lot of different cancers, is translocated onto 14. And then this little piece of 14 ends up over on 8. The MYC gene is involved in apoptosis. That means slowing down cell growth, cell proliferation, angiogenesis. So when MYC is translocated somewhere else, it can cause cells to not stop growing and increase blood supply, which is another great thing cancers love to do. So it's actually involved in a lot of different cancers, especially lymphomas, and the pathologist always wants to know if the MYC is involved. Now, remember when we talked about translocations with BCR-ABL, that there's a fusion between two chromosomes? In this case, this MYC gene, when it gets broken apart, it doesn't do its job right, which means it doesn't slow down cell growth. So for the in the 814, the MYC is on 8, and the IgH, which is a growth factor, is on 14. And so what you would expect is if the MYC is together, you see two yellows. But when it's broken apart,